This is Saxon Algebra 1, Lesson 113, and we're talking about interpreting the discriminant. Now, it sounds like it's going to be exciting and difficult, but once you see how easy this is, and I alluded to it in our quadratic formula problem or lesson set, I think you'll find this is a very simple concept. So, if we write the standard form of a quadratic equation, which is ax squared plus bx plus c, remember these are a is standing for the coefficient. If this was like 2x squared plus 3x plus 4, a would be 2, then b would be 3, and c would be 4. Now, this right here is our quadratic equation, okay, our quadratic formula. This is an equation of a quadratic or a trinomial that happens to be quadratic. This right here is our equation that we're using. And notice there, negative b plus or minus the root of b squared minus 4ac all over 2a. This part underneath the radical is called our discriminant. Now, the reason why it's called the discriminant, and we have such a negative connotation with the word discriminant or discriminant, and it means to be able to determine or to decide on something based on given criteria. So the discriminant is going to determine what our quadratic equation, okay, is going to actually do. All right, so let's look at a couple of three different versions of this. Okay, look at this expression below. Consider the graphs and the value of the discriminant for each equation. And I've got x squared minus 4x plus 3. Now let's go ahead and first of all label a, which is an understood 1, b, which is a negative 4, and c is 3. It's very important that we have these labeled. Now, we are going to use b, a, and c in our discriminant. And we're going to only use a, b, and c, and only the discriminant to figure something out. When I do so, I will put in my b is negative 4, but remember the negative is on the inside of the parentheses. That becomes squared, so 16 minus 4 times 3, which is 12, which is 4. 16 minus 12 is 4. This has a positive discriminant, okay? And it happens to have 2 intercepts. Now, they went ahead and graphed this, and I want you to notice this graph over here. If you notice that it crosses the x line in 2 places. Anytime the b squared minus 4ac is a positive number, okay, it is going to cross in exactly 2 places. Now, what's the other possibilities for my discriminant? This underneath here could be positive, it could be negative, and it could be 0. And let's talk about what happens when it's 0. This one here, x squared minus 4x plus 4 equals 0. I'm going to plug in my 1, my 4, and or negative 4 and 4. And when I do so a is 1, b is negative 4, c is 4. When I plug it in, I get 0. Now, I want us to notice something here. The discriminant is 0, and it crosses in only one place. There's something else that's unique in this, and that is that if I looked at this trinomial here, it happens to be a perfect square trinomial, which it's a perfect square. And we'll notice how that works a little bit later. But perfect squares happen to have only one point that they cross, and that happens to be when the discriminant is 0. Now, let's look at the last one. And here we go. X squared minus 4x plus 5, a is 1, b is negative 4, c is 5. I plug that into my b squared minus 4ac, so negative 4 squared minus 20 gives me a negative 4. Okay, now this one is unique because if I look at the graph here, how many times does it cross the x line? And the correct answer is none. So, and the reason being, if I look at this, and if I put this discriminant back into my formula up here, notice what would happen is it would cause the root of a negative number. There are no real roots. It crosses this line imaginarily only, and we'll talk about that in a later course. But for this one, all we have to do with the discriminant is say if the discriminant is positive, it crosses in 2 places. If the discriminant is negative, it doesn't cross at all. If the discriminant is 0, it crosses in one place. And so those are my 3 options for my discriminant, and that's how to use it. Now, I sum that up. They went ahead and put it in this wonderful blue box for you. And students find this confusing. Follow along with me here. They're saying a cannot be 0. Why cannot a not be 0? Well, it wouldn't be quadratic if a was 0. Okay, so if a has to be 1 or another number, it cannot be 0 because that would just make this like this, right? 0 term would cause this to be bx plus c, and that would be linear, not quadratic. So, and then they say the discriminant's b squared minus 4ac, which is the part underneath the radical for the quadratic formula. And then I look at it and realize that if b squared minus 4ac is less than 0, there's no real solutions. If it's equal to 0, there's 1. If it's greater than 0, there's 2. And it's that easy, and we can go through these. Look at example 1, and we'll go through it one more time on this one. Notice that I'm going to say A is 1, B is negative 3, and C is 9. So I start plugging these in. So negative b, right? So a b squared, so that becomes a negative 3 squared, which is 9, minus 4 times 1 times 9, which is 36, right? 9 minus 36, negative 27. I can stop there because there's no real solutions. And why? Because underneath the radical ends up as a square root.